Okay, what evaluates a learning algorithm? Objective function. You guys are so slow. Okay, what evaluates a hypothesis? Model. Come on. You got a whole classroom. You're just battling against me. What evaluates an input vector or a feature vector? That's the model. Wait a minute. Now I'm which one did I do? I did one of those wrong. This one's wrong. What evaluates a hypothesis is an objective function. Ooh. That means this one is not G. That's cross-validation. Gah! If I can't even get my own test right, how can I expect you guys to? I'm sorry. Let's talk this through really slowly. Do you see how cross-validation evaluates a learning algorithm? What's a learning algorithm? Like neural net, right? It trains it and tests it in one pass. So a whole learning algorithm is done by cross-validation. A hypothesis. What is a hypothesis? Yeah, that's your neural net with its current set of weights. That's one trained neural net. If you have a trained neural net, how do you evaluate it? You see, that's the thing you're trying to minimize, is how you evaluate the neural net with your data. Okay. And evaluating inputs, that's what a model does. It takes your inputs and produces outputs. Okay. Seeks the inputs that lead to desired outputs. What was I thinking there? It says it's T, inference. Ah, yes. That's coming up on the next assignment. This is one I definitely did not cover. I'm very sorry. You shouldn't have had to answer that question. But if you did the whole process of elimination thing, you should have got it anyway. And a few of you did, so good job. Okay, what trains an Elman network? Backprop through time. That's what I want to cover today if I can get to it. Oh, there's a lot of them. And basically, you just go through and use your intuition. Can we call that good? I gotta give you the answers, don't I? Let me just give you the answers. Then you can go through and hit stop on the video if you really care. So, this one is J. This one is K. This one is S. W, P, X. Y. L. N. Q. Q, D, and U. There, now you can go watch the video and check it for errors and call me on any mistakes and that kind of a thing. We have now gone through the test. I'll hand them back at the end of class, and I have a few minutes that I can use to talk about some actual content. So let's do that. Any questions on the test before I dive into lecture mode? Okay, excellent. How's your assignment going? By which I mean the time series prediction one. I've been seeing some chit-chat on the forum. That's good. Love to see that. Let me emphasize some of the lessons I think I'm seeing. So here's some data. Well, the first thing I'm noticing is a lot of people seem to be reinventing their neural networks for this assignment. My original thinking was you shouldn't have to write a new neural network every time we do an assignment. Yes, this one's a little different than your previous ones, but the model that I gave you should be flexible enough to just handle this, I think. If you find yourself reinventing backpropagation in order to handle this assignment, I'm going to claim your model wasn't very general and you just learned a valuable lesson. Write general purpose code. Don't keep rewriting specific purpose code. That was my intention anyway. If you want to write a new neural net from scratch every time, great, you'll learn more. Get that initialization. What else? Is it clear that you are still supposed to use many training epochs and you're going to present all of the training patterns in random order? Okay, what was that?
All the training patterns in random order?
Yeah. So, in this case you can. If we were training a recurrent neural net, you couldn't. In this case you can. Here's why. So, you have a whole bunch of features, which are not these numbers I'm highlighting. They're basically tick marks on the number line. They're all the values from 0 to 1. And these are the corresponding labels. You caught that, right? Now, as long as you know which feature goes with which label, you could jump all around the number line and present them, is what I claim. So, yeah.
Will it ruin your data if you don't shuffle?
Truthfully, I don't know because I only implemented it to do the shuffling.
I got bad results if I didn't shuffle.
You did not shuffle and got bad results.
I didn't shuffle, but I got fine results, or at least I think they were fine. It seemed to be.
Okay. Yeah.
I just had a question about it.
Oh, okay. Well, I guess I'm hearing mixed results, so it might work if you shuffle, it might work if you don't. I shuffled, and I think you would by default because that's how our neural nets usually work. Because this is a regression problem, we can. Meaning, think of it this way. Your neural net is a big sheet of tin, and we're trying to bang that tin to fit to the data, right? Now we have all this data. Which do you think is going to work better? If you follow along the tin and keep tapping on it until it fits to all the data, or if you jump over here and bang it and then jump over here and bang it. Actually, that first one sounded like it worked pretty well. But you'd have to keep going back and fixing it, right? Because by the time you get to the end and you bang on that tin a little bit, the start's kind of drifted from where it originally meant to. Whereas if you jump all around, it just works better when you shuffle, is my real message here. I think, in general. Okay, anybody have any other comments on shuffling? Okay. Yes, you can, even though it's temporal, because it's we're doing it in the regression approach. You had a comment or a question?
Yeah, all of my weights just kind of approach infinity and predict NaN.
All your weights approach infinity and predict NaN. That's bad. Why is that? Could be weight initialization. Try a smaller learning rate is my first suggestion. Here's why. You know how the output layer of this thing is linear? Where does it say that? Well, the third layer 3 in this model is linear. One of the things that the tanh function does in a neural network is it squashes the values. They all fall between 0 and 1. That has the beneficial advantage of meaning your error is always going to be reasonably small, right? Whereas if the output layer is linear, it's possible that your model is way off from the value you're trying to predict. And that can actually cause crazy large effects through the neural network as you backpropagate. So a smaller learning rate will sometimes greatly stabilize neural nets, especially when there's no activation function on the output layer. Yeah?
So I tried to go through like the debug speed here at the bottom.
Okay.
One part of it that I don't understand even if I do it by hand.
Yes.
And that is the gradient for the end weight, like in the last layer.
Okay. Oh, now that you mention it, I want to point out one thing. This debug speed does go through in order without shuffling. And that could give you the impression that you should do that too. The reason I did it in the debug spew is I didn't want to have to tell you the order in which I did it, and that would be a pain to code up. So, yeah, the debug speed does go through in sequential order, but that's only for debugging purposes. By the time you try to produce your results, you want to shuffle. Okay. I missed the thing you said because I had that thought. What was that?
The gradient for the weights of the second.
Gradient.
Zero.
Okay, let's see. Hidden blame, weight deltas.
That's the first one. So your input was 0, so that makes sense there.
Oh, okay. So we're going to go down to the second one.
Yeah. That one.
bias
they're all zeros
deltas.
again.
Okay.
I don't know where all those zeros came from. Because your activation input is like a bunch of near zero values for the first 50 and then 1 for the next 50. And then your blame for the last layer is like 2.9.
Okay. You know, I made this debug spew a few years ago, and my mind is not latching on to it like it should. I don't think I can help you on my feet right now. I think I'm going to have to take this after class. Let me ask you, is this debug spew helpful, or have you guys all generally found that it's kind of off? Is it,
This would be too much, but
I give too much output?
I mean, the network is so big. I think you can generate a smaller network like 3 sigmoid, 1 linear, and then it's easier to keep track of everything. It's like just
I see. So it's overwhelming.
yeah.
Got it. I'm sorry about that. I guess I could put together a smaller one.
And you can choose the number.
Yeah, I figured by this point everybody's neural net just works, and so it's more a matter of hammering out the little details. Well, I guess I'll have to do that. I'll try to make a simpler model that can get this working, and then we'll have some debug speed to work with. Yeah.
Well, there's like 700-ish rows in the ARC data.
Yes.
We use like 256 to train, and then we only pick 300 something.
Ah.
Why?
No good reason. I scraped all the data I could, and I happened to like that particular spot in the data. Well, I picked 256 because it was a power of 2. I plotted the results. It looked pretty good, and therefore I just went with it. Any point in the data would be perfectly fine to call between training and test, and presumably you should get good results. I hope you guys will fiddle and not just do the one cut that I gave to you. And you'll see that it doesn't always produce great results, and that's good to know because this is not the world's greatest time series predicting model. It's just a decent one. Yeah, I don't have a great reason. That's just what I did, and it worked. And once I make my assignment instructions, it's easy to just not change them next time. I guess that's the real reason. All right, so I'm guessing this debug spew is insufficient. How many people have got this working? There's a few. Okay, good. So it's doable. Good to know. I'll try to get some debug spew produced really fast. As long as nobody comes to my office after class, I'll be able to get that done. But I know somebody's going to.
How do you
So,
work?
what's that?
How do you claim it works again?
How do I claim it works? Here's why I claim it works, because last year everybody did it and theirs all worked. So they all produced a bunch of charts and they looked like the one in my paper. So yeah, I haven't touched it since, so unless math has changed, I'm pretty sure it still works. Yeah.
I'm getting the right general trends, but the actual unemployment goes up to like 9%, and I'm
Okay.
not quite getting that magnitude, because that's higher than anything that's in the actual training data.
Ah.
Is there any way to predict that, or is that just like impossible?
It's not impossible. I don't know that we'll ever get great predictions. The main reason is this: time series prediction is hard. And that's not a fault of the model per se. It's the fact that it just can't be done. I don't think there is any time series model in the world that will do a perfect job on this. Having said that, I did make one slight little change here. See how it says regularize only the outbound weights from the sinusoids, don't regularize the bias terms or the weights from the one hidden linear unit. If you started before I changed this sentence, I try not to change my instructions, but this one needed a little adjustment. Yeah.
We usually just regularize weight, not the bias. Or
Usually you regularize everything, but I have found in this particular data the bias is critical because the values range from like 0 to 10 or 1 to 10 or something like that, and that's a pretty big span. And if you regularize the biases, it crushes it down so that it doesn't fit it well. And I also say don't regularize the weight from the one hidden linear unit because it's supposed to learn that there's a general slight upward trend, and that helps it make a bigger prediction at the end. So that not regularizing some of those terms should help you get those values. If that doesn't do it, then I guess we're reaching the limits of my knowledge. I don't know what to do to make it work. Train longer or shorter, fiddle with it, try different units, experiment, and do a bunch of research and then publish it. That's about what I've got for you. Okay, yeah.
I only regularize the weight. Yeah, not the height.
Okay.
Of the last. For each linear.
So
layer.
just on the output layer and just for all of the sinusoid units, is that right?
Yeah.
Yeah, that's what I find works best for this problem. Now, most problems, you're going to regularize all the weights, and that's just what you do. Okay. Well, I had intended to talk about recurrent neural nets, but I've only got 3 minutes, and that just can't be done. So I'll stop here. Any other questions on this assignment? Yeah.
What SSE did you get on the data?
SSE. Do I even measure SSE? I don't tell you to measure SSE, and so I didn't, and I have no idea. Anybody else happen to know the answer to that? Yeah.
I measured SSE and it's really misleading because some of my lowest values for it were just predict for forever.
Ah.
So it's not really.
So thank you for confirming something I taught last time. Yeah, SSE is a bad metric for evaluating time series prediction. So basically, don't even bother measuring it.